Alright everyone, finally the wait is over. I just completed assembly all the wires I needed to connect to the Nakamichi 1000ZXL deck, this test unit. I tested that all wires are properly have a good contact to all pins on all connectors. I make marks on every connector to make sure I clearly understand which one is which and where they should be connected on the board. And I made 1 meter long wires so I would not be struggling where I will put my test unit. And it's time to start tuning this nice deck. All right, so let me prepare everything and I'll meet you there. All right. Board is connected. As you may see, we have wires. What's the tricky part? These connectors didn't fit due to how they set in the board, so I had to cut these like limiters on the edges in between 4th and 5th and 6th, right, to make them fit. Here you may see they fit perfectly well, 7 and 8, right? But here I had to cut this side limiters. So when you install, you should be very careful when you're installing. And 3 connectors right there on the RAM board. All right, so it's time to connect, power on, and start tuning. Okay everyone, I'm started tuning and I'm using the updated manual piece for tuning with this unit, and I received it from Jan. It's Vidi Cassette deck restoration from Europe. Very nice channel. I highly recommend you to take a look. He is restoring Nakamichi and other decks and currently working on Nakamichi 1000ZXL as well. So he sent me this unit and we become friends. We chat a lot about different decks, different issues we observed. So guys, go ahead and subscribe. Really nice channel. So the step 1 is the maximum BS current adjustment. All right, so that's why we have to use step 10 of this manual, and we have to measure voltage across resistors which sits on the output of the bias. So technically they are just here on the connector R125 and 225, and they sit 10 ohm resistor sits between the pin on the connector and the ground, right? So we have a lower voltage, not the full bias voltage. I'm connected the ground pin right here to this checkpoint. I believe it's checkpoint 10, and I'm measuring with my probe on pin 1 and pin 3, right? And look at the values on the VTVM. So to get here, first of all I have to set the pin positions, pin switch positions from the instructions, the first channel, like that. All right, and then click SW2 button, and it's bring power to the first channel, and I was able to observe the first pin. Let me do it. And if I connect right here to the pin 1, I can see a value on my VTVM. It's currently around 45 millivolts. And then we have to adjust peaking. I'm using this my plastic screwdriver. Sorry, where I put it here. All right, and I've been adjusting this coil and this coil for this channel, right, to get maximum value. Like these coils appear to be like fully off, like fully counterclockwise, and they've been here. And I tried like to tune, peaking is reduced, and with these 2 coils I was able to set current peaking and get the maximum value. That's what we need to achieve. Now I will move to step 2, and we will be tuning the other 2 coils. And that's step 3, we will be tuning levels, bias levels, using these 2 pots. All right. So moving on step by step. So far everything works. See you. All right, I just completed step 11, bias trap adjustment. Our programming steps here on the unit are the same as the first step, but measurement points right here on these two terminals. So right here, one channel, then another channel. Like so, we do like that. Click one channel, and then we use this bit and click, and we get other channel. We measure voltage on these coils. I had to switch to 300 millivolts because it showed me around like 110, 120 millivolts. And by adjusting these two coils, I was able to lower it by 20 millivolts. So we need to achieve a lowest reading in these 2 points. All right. So next would be the bias levels. I believe it's step 12. Yeah, bias current adjustment. So to do it, we have to measure again output on these terminals here, 1 and 3. But we have to set different bits. And our goal, obtain 80 millivolts on VTVM. All right, it would be maximum reading. So let's go right here. Bias current adjustment. Okay, we have 4 settings. Why 4? I thought left right channel. What would be the difference? Here with 1 bit and here with 1 switching bit left right. So switch 6 switching between left right, and I need to say what's between bit 3 and 4. What's the difference? Back. Step 12. Trigger. Then press trigger. We have 4 combinations for this unit, and let's see when we will get 80 millivolts. I will tell you in a moment. All right. So what happened? When I set the first 2 combinations, I was not able to get to the maximum bias. We need 80 millivolts to be set up, but one channel was like between 650 and other channel was 550 millivolts. Right, I cannot go above that, but when I switch it to the second combination, levels increased, and then I was able to set first channel and then the second channel 80 millivolts as in instruction for bias current. All right, so technically the small bit switch 6 controls left right channel, so you have to program first combination, then the third one, and you will get left channel, and then second and fourth, and you will get the right channel, would be able to adjust your bias current. All right, next would be oscillator levels, and then we'll switch to AD converter. All right, now let's see step 13. We need to connect VTVM to test point on main PCB. All right, and we will adjust ports on the CPU PCB-A, and that's the instruction. Okay, let me read this through. Let me reconnect my VTVM, and let's see how properly adjust this guy. See you soon. All right, guys, next step would be interesting. We have to remove these 2 boards, playback board and Dolby board, and make a connector or shortcut, you see, to conduct left-right channel, input to output. All right, and that's how we will be tuning levels. Really interesting. They recommend to solder wires down below. I made a jump wire with connectors to be able to easily install and remove it when needed. All right, moving to the next step. See you in a moment. Looks like I'm stuck a little bit, so I can set like codes. I can engage internal generator. It should be 400 gears, but it shows 387 gears, which is pretty close to what we need. I can set 0 decibel, I can set minus 10 decibel level, right? But this signal with these removed boards does not show me anything on VTVM, which is connected to the test points. All right, so here I'm connected to the output of the CPU board, when I can control it and see. So for example, let me reduce the amplitude here, so you would be able to see. So that's the small amplitude. Peak to peak is 2.6 volts. It's minus 10 decibel. And to get 0 decibel, we need to apply different code. We need to remove this one, turn on this one, and click the button. Bam. Probably we need to start over the test steps. Let's try one more time. I'm so tired with this procedure. It's way overcomplicated. Like they could put like a button here, click, 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 click. You switch through the modes, adjust everything, done. That's how I did program like microcontrollers in 1980s, 1990s. Way too complex procedure, right? Power on, wait till tape transport. Let us activate, done. Turn on the signal. All right, switch everything off. Oscillator levels, 4 zeros, 0, 1, 0, and then 1, 0, 0, 0. Okay, and switch 1. It starts blinking with bias, and it sets automatic equalization. Next, 1, 0, 0, 1, 0, 0, 0, 0, 0, 1. And it's, see, nothing on the output. And now when I click, yeah, it shows peak to peak 7 volt. All right, like that. So it's 1 volt. 676. More precise. Now we will code it to the minus 10. We will switch here, and click button. Bam. And peak to peak is 2.24 volts. Like it dropped 3 times. Right? We get minus 10 decibel. But I don't have anything on the output. I check it schematic. I don't understand. Like this signal goes to the record amp board, right? Record Dolby, and after it should go to the output, and then it connects between playback, what we put a shortcut wire, and then it goes to the test points. But without the record Dolby board, so there is just no connectivity. So let me show you what's happening. So that's, I'm measuring currently on the output of this generator. All right here, CM7. And then it goes right here. Here, MC7 oscillator. Through 1 microfarad capacitor, it goes to the oscillator in on the Dolby board, right? And it's pin 6 of the connector CN48. Then pin 6 goes through resistors on both channels input here. 47 kilo ohm, 124 and 224, and it should go to the Dolby, and then it should go to the output, and then from this output with our shortcut, it should go. My understanding that Dolby board has to be installed, otherwise like we cannot measure. Let me try. Like that means like I have to do shortcut wires. So because connector will be busy with the board. So I believe that's error in the manual, and we have to change this behavior because we cannot measure anything on the output. All right. And I'm so happy with my lazy Susan. I can now easily rotate the deck. It don't prevents me from movement. All right. See you soon. Hey guys, I was correct. As soon as I installed back record Dolby board and connected the wires on the main board, set the codes for oscillation, and I have 310 millivolts. And we need 300. It's 31 millivolts, and we need to set 28.5 by adjusting VR 301. All right, I need my tool. Let me see, slowly rotate everything. VR 301. It's upside down. All right, let me check which one is which. All right, 301 is the lowest right here. See, that's 301, 302, 303, 304. That's for levels. I just adjusted to make it 28.5 millivolts. All right, now let me set next mode and adjust next frequencies. Finally, I solved this puzzle. Hey guys, it's been a full day while I've been tuning this deck. It drives me crazy. There is errors in the service manual, and like to make it running, it requires lots of efforts. All right, now it calibrates, as you may see. It records flat, like up to 27 kilohertz on type 1 tape. Really incredible recording at 120 microseconds. Let's see a level. So that's the source tape. The difference is like 0.2 decibel on one channel. That's how it calibrates. It's perfectly well. Wow, when flutter is low, everything is flat, but I'm really exhausted. Like the steps to tune up the bias, like and everything here is obvious. But steps just to tune up these 6 spots, that's nightmare, really. I had to measure with oscilloscope levels, like generator levels, RMS, on VTVM, like had to run codes. When you run, it stucks, like reset doesn't work. You have to disconnect connectors, like 2 of them, like number 7, number 5, which maintains those reset signals. Then turn it off, turn it on, run it so it's reset itself. Then connect again, like turn it off, connect again, turn on, start procedure from the beginning. If you went through the steps, sometimes it would not go back on the steps, and you have to start over again and again and again, and it's exhausting. All right, and instructions doesn't work fully. Like it sets to maintain like specific levels. No, it's not. It's tune it level like on the deck, and it was like relatively fine. I did this very minor adjustments. All right. The main reason was like that's 400 gears comparing to other levels was way higher. All right, so it was like 31 millivolt versus 28.5. Everything else was spot on. Like I almost don't need any tuning. But to compare everything, to measure everything, to adjust those digital codes, subtracts, and it might be done way simpler. Take a look at the similar decks from the era, like Akai, GX9, F91, R99, like those been done way easy. Like you adjust two ports, right? Yeah, like considering that it's like adjusts every channel separately, right? It's fine, but the generator is the same. Just like measure voltage levels, adjust tune DC levels. There is like compare, like AD transformer, like right. It would be way easier than they did. Like I'm not sure what they think of, and like I have read articles in the internet, and like guys like wrote that when they had an issue, recommendation was, oh, send to manufacturer, they will tune it up. All right. Oh my. So now I have just a few steps left to complete, and it will be done. And it's still pending one upgrade. I want to remove mute transistors. It's not exactly the same clear as my 680. I wanted to make clear. And you know what? I was thinking more like, why this deck and 680 sounds like more live, more natural. I believe I have glue. Both decks employ RAM control, right? And RAM control is operates on 5 Hz mode. That means that these decks have to reproduce 5 Hz whenever what. And that makes them like the best decks from everything I have heard so far. All right, hope you enjoyed my channel. That's really way much time for this deck. I spent a month to recap and then another month to tune it, really, to manufacture unit, to spend that much time tuning this deck. I never thought that it would be that complicated, all right, that complex. I believe that would be it for tonight. I'm really exhausted. I spent full day working on this deck, and believe me, it's way too much. Excuse me. So if you would consider to work on these decks, good luck to you. But I believe it's easier just to build new boards like with custom CPU and like run everything right away like, with a custom program. It would be way easier than like try to restore all those parts. Yeah, genuinely is fine, interesting, like everyone likes it, but that's it. I'm also thinking about like do conformant coating for this board, so like remove the smell they produce. I still will be experimenting, so stay tuned to my channel. It's getting better. It's not that bad, like just like a little bit, but my spouse don't like the smell from these decks. All right, hope you enjoyed my channel. See you and bye-bye.